Determinant and inverse of matrices have essential role in solving systems of linear equations, so it is important that you know them and know how to use them. The determinant is a useful value that can be computed from the elements of a square matrix. In MATLAB, that function performs this operation. This function returns a scalar value that equals to determinant of input matrix. For example, assume that we define our desired matrix as follows: -1, 5, 6, 7, 8, 6, -5, 1, 2. And now type that x and hit enter. You can see the output of this function is only a number. This number have an important rule. We will know that rule in future lectures. Note that the determinant only works on a square matrix, and for non-square matrix is undefined. And note that the determinant of identity matrix always is 1. For example, and data of I. This determinant is equal to multiplication of all diagonal elements. To solve a system of linear equations, you must use inverse matrix operation. For 2 by 2 and 3 by 3 matrices, you can do that manually, but for bigger matrices, you can't calculate them manually. Im function is another MATLAB built-in function that performs this task easily. For better understanding, type inv x. Capital X. As you see, the inverse of matrix X calculated easily and without pain. If you multiply X to its inverse, you will obtain an identity matrix with the order of original matrix. Matrix trace is the sum of diagonal elements. Note that the trace is only defined for a square matrix. For calculating trace, you have two ways. First way is finding diagonal elements of matrix by diag comment and sum them. Second way is straightforward. You must only use trace comment. For example, assume that we want to know the trace of matrix X. Only type trace and X and press enter. As you see, the output of this command is only a number. That's right. In this lecture, we learn how to use more advanced operations on matrices. In the next lectures, we're going to learn how to programming with MATLAB. Thank you.